Lab 6 dash 1 number 3. So this one is to practice to get used to the new equipment. So right here we have the new board that is called Arduino Mega and the LCD. So how this stuff is work, how is function, what is proposed for this one. We have the one push button here. That one is connect to the digital port, and we have potentiometer. This one is connect to analog port A1, pin number 2, and the LED. So the LED is gonna show the information of the analog value that we got from the potentiometer, and push button show the state that is being pushed or not being pushed, not push or not push. The code is already provided. Try to turn the potentiometer, and you will see the value that's decreasing and increasing. So this one, the status of push button is not being pushed yet, and okay, when push is gonna show that the bottom is pushed. So the new of this one is a LCD. The LCD is we need to use the function that we call include, that we can download from the library. So the LED is look like add an object to the program. This is lab 6, that 2, number 7. So this one is designed to practice to control the servo motor. So the code is already provided. So I'm already download to the app Arduino. So the step to turn the what we need for this circuit. So we need the servo motor, we have the axle, we have the we connect this one to pin number 3, and we have USB connect to the power, and let's see how it happen. So this one I use the to download the include servo library. So the function of that give for the servo motor is gonna start with the 45 degree and going back to 0, and it's gonna go to the 45 degree and then 0, and then go back to 90, and then go to the 135 and go to the 180 and go back to 90. All right, and this is the code that is already provided. Thank you. Lab 6.3, number 9. So this one we continue practice on servo motor. So for this one we got the exercise that we're gonna write the value, we're gonna print the value on the screen. It's gonna have the value of the potentiometer, and it's have the value of the motor that is turned. All right, so what we have in the circuit, we have the servo motor, axle from with a little flat, potentiometer and axle, So the potentiometer is attached to analog pin A0, and the servo motor is going to attach to pin number 2, is a digital pin. The course I'm already coding and already download to the board, and then see how it's work. Alright, so I'm gonna turn the potentiometer, and you will see the movement of the servo motor. The servo motor is gonna follow every time that turn the potentiometer. So the pot value is can read from 0 to 1023. So that's the maximum value, and then the maximum angle of the motor is 180. Actually, it's like a 0 is full speed in one direction, and at 90 it's gonna be a neutron or stop, and 180 is gonna be full state, full in opposite direction of the angle 0. And we're gonna see the code.
So this one is have two objects that we attach to the board. Firstly is a LCD, and the second one is a servo. So we need to download the library, the include one and the servo one. And the value that of the LCD is already set, and for the servo is pretty much the same from the previous video. We just change a little bit. I mean the word that we're gonna print on the screen, like the name of the project is pot control servo, and the pot value or the angular value. In here, I set the serial communication at 9600, and we're gonna attach the variable to pin number 2 and A0 as a pot value. Pin A0 as the analog to read the value from the pot in the while loop. So we have we need the value from analog read, so we store in the pot value, and the value that we read from the potentiometer is cannot write directly to the motor, so we need to map it. So I mapped the value 0 from 0 to 1023 to 0 to 180. That's the angular value. After map it, so I'm gonna write the value to the servo by the function right.
This is lab 6.4 DC motor number 12. So this one we're gonna work with the 2 push bottom. So we have 2 push bottom. We have the DC motor. We have the motor controller. So because of the DC motor, we only have 2 wire. We need a controller that able to get the signal to send and receive feedback to the Arduino. So that's why is a controller is needed. Okay. So how this exercise, I'm sorry, what the exercise is about. we have the two push button. One is gonna control the motor go forward, and the second one is gonna make the go backward. I'm already download the program to the Arduino and see how it's work. As you see, the status bar is going to show the it's running in direction forward, and the second one is to show running and going backward. Lab 6.5, number 13, conveyor simulation. So this one we're gonna work with the potentiometer and two push button and the DC motor. The assignment is if the start button, I assign this one as a start button, this one is a stop button. If this one being pushed, the motor is keep continue, and when the stop is being pushed, it's gonna stop. I'm already write out the code and did download to the Arduino. And how is wiring? So the motor is got the power from the battery, and the potentiometer is connected to the analog. The two push button connect at the digital port, and the motor connect to a motor section because it's gonna got the power from the battery. And let's see how it's work. I'm gonna do start. Okay, and motor is keep running. The other assignment is we can adjust the speed of the motor. So at the specification, this motor is the top speed is 100 RPM. So I mapped the value from 0 to 100. Slightly increasing the value, so the motor is start spinning to the top one. Okay, and then I'm gonna stop. Alright, and let's see the code.
So we have the LED as an object and the a motor as an object too. So we need to add the libraries. For the liquid LCD is already provided by Mr. Kim Chansky, and except the include that we need to working on that. Typically is as much the same, so I'm create a servo object for the DC motor, and the LCD setup is pretty much the same. I get the set the serial communication at 9 and 600, and I'm attached a variable to pin, actually it's supposed to be pin 30. Okay, and pin number 3 and number 4 as the input for the push button, start and stop. 3 is a start, 4 is stop. 0 is analog port for potentiometer. In the while loop, so this one is keep repeating. At first I define the start and stop push button, and then use the function y the start button low is mean being pushed, because as we use the input pull up, so it's gonna tie the pin in the high volt. It's not floating, so that one is it's not 0, it's gonna be 1. So when it's being pushed, so it's gonna change. They're gonna read the low signal. So why the push button being pushed? So it's gonna read the analog value from the port value, and then I'm map it the value for the motor. So the potentiometer is read the value from 0 to 1020, 23, and I'm gonna map it to 90 to 170. 90 is gonna be the motor is gonna stop. This one is the angle, and 170 is gonna be the motor is gonna run in a counterclockwise and keep continue. I was set is 180, but in 180 it's gonna stop. It's not fully speed. So I was trial and error. I mean to see how the motor works. So from 0 is to 10 is not move, but it start to move from 20 to 80. So this one is going will clockwise. When 90 to 100 is have the sound but it's not move. But then is 110 to 90 is moved, but in the opposite way, in counterclockwise. So that's why I set the value from 90, that is mean stop, to and turn counterclockwise. I mean it's running to the 170. So I passing the value to the motor. So the value that motor is got is a 90 to 170. But the value that show on the LCD is gonna be, I'm gonna map it again. The length of value is a 90 to 70. I'm convert it to 0 to 100. Why I get this number? Because at the specification was said that is free speed. So this motor doesn't tie with anything yet. So I think its full speed is probably is 100 RPM. So that's why I'm convert it to 100. And so the motor is keep running until the stop button being pushed. It's gonna break from that loop and gonna ride the motor at 0. 0 is mean stop. I would upload again and try to work with this one again. I'm gonna start. Okay.
Change the speed of motor. Okay. Alright. And then